Okay, here I will demonstrate the calculation for the first part, task 1 of homework number 3 for Kines 402 here. So here I've copied in the information that you're given in the homework prompt for the 3 athletes in question. So it gives you their body mass in kilos, their stride rate in hertz or strides per second, and then their contact time in seconds. So body mass here, that's hopefully self-explanatory. Stride rate, that's how many strides you complete per second. And contact time here is unilaterally, so for just one side of the body, how much time you spend per stride with your foot on the ground. Okay, so our goal here is we want to calculate the average vertical force that the athlete produces to sprint with these mechanics over here in multiples of body weight. Okay, in terms of like a fraction of the body weight here is how we're going to express that force. Our reason that we want to express the force like that is in terms of newtons per body weight for the average vertical force there. Calls back to that weigh-in paper in the sprinting section where the higher that average vertical force per unit body weight was, generally the faster sprinter the person was. Okay, so stride time is pretty easy. That's the seconds that it takes to complete a stride, or seconds per stride. We have stride rate over here, which is strides per second. So if we just do 1 over stride rate, that gets us our stride time in seconds. Body weight, that's an easy one. We take body mass times 9.81 meters per second squared. Gravity, that gets us body weight. Our average vertical contact force, or our average vertical ground reaction force, FC there, that's the average force that I have to produce against the ground or the average force that I produce against the ground when I'm running. And how can I figure that out? I can figure that out by knowing that the average force that I produce over the whole stride is equal to my body weight, which means the impulse that I have to produce during that stride is going to be my body weight times the stride duration, or the amount of time that I'm producing that force on average. But then I only have the contact time here, the amount of time that my foot's on the ground to actually produce that force. Okay. So here, first in my cell G here, I'm going to take body weight times stride time. And that gets me a number about 410 there. That's not my average vertical force. I'm not done yet. That's my vertical impulse that I produce against the ground with my feet over the entire stride. Okay, so body weight, which I know is the force I have to average over the whole stride to not fall over, times the stride time, or the amount of time that I'm producing that force on average. That's this impulse here. Okay? But the time that I have available to produce that force is the time when my foot's on the ground, which is this duration of time, this shorter 0.105 seconds, not this time here, the 0.529 seconds. That's the whole stride time, which includes the airborne phase of the stride when my foot's not on the ground and can't produce any force. Okay? So the average force that I have to produce when my foot's on the ground is actually going to be quite a bit bigger than my body weight. And how much bigger? Well, I know when I've got my foot on the ground, I have to produce this impulse here so that I'm offsetting gravity, but I've only got this amount of time to do it. Okay? So I'm going to take that impulse, force times time, and divide it by that amount of time that I have available to actually produce the force. And what's left over there, that 3,900 or so newtons, that's my average force that I'm producing during that contact time to offset gravity in the vertical direction. So that's in units of newtons in cell G there. And to get it in units of multiples of body weight, or newtons per body weight, I just take those newtons and divide them by my body weight. Okay, now got about a number about 5 there, five body weights on average for my vertical force in sprinting. That's really high. If you go look at the weigh-in paper, they get numbers that are more like 2 to 3 times body weight. What's wrong here is that this stride time is the time to complete a whole stride, but this contact time is just for one step. Okay, and in each stride, there's 2 steps. There's a contact for the left foot and a contact for the right foot. Okay? So when I'm calculating my average force here, I actually need to divide it by not just the contact time, but 2 times the contact time. Okay? Because there's 2 periods of foot-ground contact, each about 0.105 seconds, during this whole stride time of 0.529 seconds. Okay? And that gets me a number here of 2.5-ish times body weight, which is more about what I would expect from the data in the weigh-in paper there. Okay, so that's for athlete 1. You can repeat that or copy-paste that for athlete 2 and athlete 3 here. Should get something in the range of 2 to 3 for all of them in terms of average vertical forces per unit body weight there if you want to check on whether that's done correctly or not. But that's a demonstration of the calculations you should be doing for task 1 in homework number 3.